No. We have covered gravity concentration and different categories of gravity concentration already completed. We also have completed growth flotation, and also we have completed heavy media separation, I told, that is gravity concentration, and other magnetic separation. So this is one of the last category of separation, that is called electric separation. Fine. So what exactly electric separation means? Separation you understood, right? Separation means we have to separate the gangue from the metallic values or main mineral values. We have to separate the gangue, right? And we can also call it as concentration also. So that's why this topic is also called electric concentration. So electric separation or electric concentration means we have to use electricity or electric field, right? We need electricity, or I can say electric field or electric forces or electric charge, whatever. Force or basically charges, electrical charge. So this is important, electrical charge. And electrical charge will be obtained by using electric field. Suppose just imagine a situation. I will collect some aluminium ore or iron ore from the nature. Will I get any shock? No. I will not get any electrical shock. It is neutral. Whatever the mineral you are getting. Suppose you are doing mineral processing also, starting with crushing, then grinding, then whatever you do in between, you do screening, you do classification, right? Whatever you are doing during mineral processing, even if you touch the mineral particles, you will not get a electric shock because it is neutral, right? But in electric separation, we are going to make the particles, these fine particles of mineral, charged. It will get charged. Either it will carry some positive charge or it will carry some negative charge. And that can be done by what? By applying electrical field. So suppose lot of minerals are there, mineral particles are there, you apply electrical field, either the particles will become positive or it will become negative. With charge. And these charged particles, the mineral which carry this charge, these charges are basically on the surface, you have to understand. These are the surface charge. Not entirely it is getting charged. The charge will be on the surface. Okay. So what is basically the principle of electric separation? Like if you remember, in magnetic separation, the magnetic behavior will decide the separation, right? Someone will be more magnetic, someone will be less magnetic, or someone will be dimagnetic, someone will be para, or someone will be dimagnetic, someone will be ferromagnetic. So difference in magnetic behavior will decide the separation, right? But in electric separation, the conductivity, the electrical conductivity will decide the separation, because certain minerals are more electrical conductive, certain minerals are less electrical conductive. Fine. Like for example, you simply can say conductor and non-conductor. Conductors and non-conductors, basically. For example, you take a metal. Metals are mostly conductors, good conductors, of course, right? But if you take a mineral directly from the nature, it is a bad conductor actually. Basically, it is a bad conductor. It will not carry. But in this electric separation, we intentionally charging the surface of the mineral, whether it is gangue or whether it is valuable mineral. The surface of the gangue mineral or valuable mineral will get charged up. Intentionally, we are charging it. Either it become positive, it become negative. Right. So that means we can say we need to separate these two things. So at the end of this electrical separation, you will get two products. One is your conductor, one is your non-conductor. In this way, you can separate them. But you will get a very interesting thing out of this. You will be able to see basically whatever you are saying conductors, they are basically gangue. You think conductor will be basically metallically, but here it is very interesting. You see these conductors will be basically your gang members. And this non-conductor will be basically your valuable members. Or metallic value, whatever you say. And I told we need to charge the mineral surface. Intentionally by applying electric field or electrical charges. Okay, let me give a good example from the physics, whatever you have studied in the school days. Have you ever heard about corona discharge? Corona discharge. That's a very interesting phenomenon. Anybody remember corona discharge? How many of you remember? Just can you raise your hand? Only 1, 2. It was there in 11th class, I guess, or in geography. Okay, anyways. Okay, fine. Okay, so this corona discharge will help you to explain the concept. I will explain the concept on the basis of this. See, for example, this is a house, fine. If you go to any taller building, big taller building, you will see, even if in your house also, you will see there will be a sharp metallic wire or sharp metallic object will be there on the top. Earthing ho jaoge, earthing. So in the tall building they will be having, suppose this is a trident, you understood, trishul, whatever. The top of the trishul or the trident is sharp. So whenever any metallic sharp object will be there, the concentration of charge will be maximum always there. You have to remember. The concentration of charge, electrical charges, will be always at the top of the sharp edges. So when there will be thunderstorm, lightning will be there. So what will happen? The lightning will be strike the sharp edges only. It will not strike the entire house, right? So when there will be lightning, it will strike here, and what happens? This is actually connected to ground. Sorry. You understood lightning? Lightning is having so high voltage is there, so much power is there in the lightning. If there will be no trident or any sharp object on the top of the building, what will happen? The building may either get hurt, collapse, or the people staying inside the building also may get electrical shock. You understand my point? They will get electrical shock, they may get die, or maybe building may collapse also. Why? Because these bricks and all have moisture, no? So what happens? This lightning is having a very high amount of electrical energy, amount of heat energy. It will volatilize all the moisture. So building may collapse also, or you may get electrical shock. So what happens? This is basically connected to the ground. So whatever lightning will happen, it will pass away. The electricity will pass away to the earth without affecting the building. So this is basically called corona discharge. So how I can draw a diagram, you can see. That is called high tension. High tension separation. So you will gonna get a question from this. So you can draw the diagram also. So you can see you have a roller. So this is your roller, made up of maybe mild steel or any conducting material, conducting metal, for example, and you allow so this is, for example, having mixture of conductor and non-conductor. Or you can understand a mixture of valuable mineral and gas. Fine. So now suppose collect them here. There will be brush. This is your brush. Or scraper, whatever you can say. So this is basically, this is your conductor. So these are the non-conductors. And this is art. See, this is a very good situation where you can see we have a roller, right? This roller is rotating like this. This roller is rotating like this, and we are feeding what? Our fine minerals, basically fine minerals having GAN as well as your valuable minerals. Both are getting fitted on the top, and it is rotating. This direction it is rotating and feeding, right? You can see there is a electrode assembly, and this is actually made up of metal. This roller is made up of mild steel or some metal, conducting metal, but it is connected to the earth. What is the function? Why it is connected to the earth? Well, electricity can pass and go to the ground. It will take away all the charge, that means. It will take away all the charge. You can see here there is an electrode assembly. So what is the function of electrode assembly is what? This electrode assembly, it is suppose maybe 50 kilovolt. It is the voltage is, you can imagine, 50 kilovolt. It is too much high. 50 kilovolt means too much high. So what exactly? Just imagine a situation. You have one electrode here. You have another electrode here. This is one electrode. This is one electrode. You are bringing two electrodes very close. Metallic electrode, right? This is one metal piece and the metal piece. You are bringing the metal piece together, and this electrode is connected to positive terminal. This electrode is connected to negative terminal of the current supply. Right. So that means you have applied 50 kilovolt. So much high voltage you have applied across the two electrodes, and you are bringing together. What will happen? Attracts. What do you think? It will generate charge. What exactly happened in between the electrodes? What is present? In between the electrodes, what is there? Air only is there. Air are nothing but the molecules. Carbon dioxide will be there, oxygen will be there, nitrogen will be there. These are the molecules of air, and they are neutral actually. But you have placed two electrodes very close, and voltage applied is very high. That means across these two electrodes, potential difference is so high, the air between these two electrodes will become ionized. It will become, that means some electron will come out from the nitrogen atom, some oxygen atom, it will become ionized. Some electron will be there, some ions will be there. So it will get charged up. Lot of charged particles will generate because of ionization of the air itself. Now, what is happening? These ions, so what will happen? This ion will fall on this particle. Suppose, let it be, just imagine the situation, negative charge. So that is nothing but, you just imagine a situation where you are bombarding ions on the mineral surfaces. This electrode assembly thing is what? It will bombard the ions on the mineral surface. These are the minerals which are going down. So what will happen? The minerals will acquire surface charges now because of the bombardment of the charges. Up to this it is fine, or again I will take? Is it fine or? So electrode assembly function is to bombard the charges on the minerals, right? So what will happen? The mineral will carry some charge on its surface, right? So what will happen exactly now? And this is a conductor, and it is connected to the ground. So whatever charge is there on the surface will travel to the roller, and finally it will move to the ground. But here interesting thing is, you have gangue mineral, you have valuable mineral. And I told you in the initial part that gangue mineral become conductor and the valuable mineral become non-conductor actually. Why this is happening? Because gangue minerals are basically, they do not flow the charges. Actually, what exactly happening over here? Suppose this is gangue, and this is valuable mineral. So both have suppose charge, negative charge now. Just imagine. Both are negatively charged. And you are bringing a conductor, for example. This is a conductor. You attach this one with this and this one with this. What will happen? Since valuable mineral, the charge can easily flow through the valuable mineral. So what will happen? Maximum charge will get flow through this, and it will go to ground. So now what will happen? They will not carry any charge, so it will not stick to the roller. It will directly fall here. But the gangue minerals, they are not good conductor actually. Actually they are not having good conductivity. The charge cannot flow within them. So charge will be still there on the surface, so it will stick to the roller. So you can see these gangue particles, they are getting charge, so they get stick. So you have a brush. So brush will do what? It will scrub the particles and it will fall here. So it becomes conductors. These are actually gangue, and these are the valuable minerals, non-conductor. You'll definitely get a question, electric separation, and you maybe high tension. What is high tension separation? Draw the diagram and explain it. Can I explain it again? If you want, I will explain it again. So function of electrode assembly is to provide charge, so that these charged particles will fall on the mineral surface, and mineral surface will become charged, right? And how the charge is forming, you understood? it has two electrodes. One electrode is connected to positive terminal, one electrode is connected to the negative terminal. And in between the electrodes, the normal atmosphere is there, which is the nitrogen, oxygen and whatever. And voltage applied is so high, automatically the gas become ionized. Because electron will come out. No? From the nitrogen atom, electron will come out, it become positive and electrons will be there, whatever. So lot of charge will come and it will fall on this. And this is a conductor. So the particles which is good conductor will flow the charge from minerals to this and to the ground. But the particles which is not flowing the charge will stick to the roller. And finally it will get separated like this. Why this is high tension? You know these overhead wire lines, the lines, electrical lines, they are high tension actually. Because they carry lot of voltage. You have seen there is a high voltage lamp is there. You see? I don't know it is working or not. If you go near to it, your hairs will stand actually. All your hairs will get stand. This hairs also get stand. Why? Because they get charged up automatically. So high voltage is there. So in the air, the charge are there, and your hair also getting charges. So they will get attracted and they will stand. So that's why the name is high tension. Voltage is so high. Okay. Maybe sir is calling. Can you add?
Yes.
So it is simply means some particles they are allowing the charge to flow through the drum, whatever this roller drum or whatever. But some particles they don't flow the charge. They will keep the charge itself. So they will stick to the drum or roller. So finally there is a scraper which will remove them. This is a scraper which will remove them and then they will get separated. So basically this conductor are gang. So like for example I can take Fe2O3 and silica. So where silica will be there? Silica will come to this side and Fe2O3 will be here. Conductor. Because Fe2O3 contains metals. So it can flow the charge through it. But silica is actually non-conductor. It cannot flow. But technically at the end this will become conductor and this will become non-conductor. Kind of. Okay. Then another one is electrostatic. Electrostatic separation, this is suppose this is positively charged. Or electron. And this is your, so this is a plate for example, and suppose electric field is there. Particles are flowing like this.
Positive charge.
This is your gang. That's very good. It's flowing.
Roller.
This is electrostatic separation. That one is high tension, this one is electrostatic. So see, this is a plate. Through the plate the minerals are flowing like this. And there is another electrode which is already positive charge for example. So what will happen? See, electric field is there and particles are flowing on the plate. So due to this electric field, in between this green and red, someone will become charged of a particular nature. Maybe for example, if I give an example of quartz. Quartz is nothing but silica, you know, and one of the major gang in any mineral, whatever mineral you choose from the earth, silica will be there in form of quartz. So basically I am giving an example of quartz. Suppose just imagine this red one is quartz. This one is your. So you want to separate quartz, which is a gangue, from this green mineral. Green mineral is valuable mineral, right? So this is your valuable mineral. So what exactly happens when you supply electric field and quartz is there? So the quartz will automatically become charged on the surface and it becomes negatively charged. It becomes negatively charged automatically. If you take any other minerals, it may become positively charged. It depends. But basically, I am giving an example where the quartz, which is the major gangue, it becomes negatively charged on the surface. So what will happen? Just see the imagine the situation. You have another electrode, which is hanging from the top. This is hanging from the top, and the charge, the minerals are flowing like this on the plate. And one of the mineral carry the quartz, which is become negatively charged. And this is positive electrode. So it will attract, it will lift. This technique is called lifting of charges. So it will lift the quartz particles, and the quartz particle will get separated out of this green mineral. So finally, what will get at the end? Bottom, what you will get? You will get only red minerals. Green minerals.
Side by side.
So finally, this red minerals will be coming here, right? Because of attraction. What is it? And the green mineral, they will fall, and they can collect it at the bottom. Electrostatic means there is a static charge on the surface. Suppose I will rub my two palms, right? I will rub it for more time, so it will automatically carry some charge, right? You have remember that, like you bring a comb,
Scale.
and it will attract your hair also sometimes. Sometimes your comb automatically attracts your hair because your hair, someone is having more positive charge, someone is having more negative charge, so they will get attracted, right? So this is about electrostatic separation. So one is high tension separation, and so if you want to compare high tension separation with electrostatic separation, then principle of electrostatic separation is what? Lifting effect. The effect is lifting. Some of the particular charge is getting lifted up by one of the electrode of negatively charged or oppositely charged, right? So this electrode is actually lifting, right? So this is called lifting effect. Lifting effect. And the first one, high tension. That is actually called pinning effect, pinning. Because you have seen the conductors get pinned. They get pinned to the roller. That's why it is called pinning effect. So this is lifting, that is pinning. So you can write a difference between high tension separation and electrostatic separation. So electrostatic separation works on the principle of lifting effect. High tension separation works on the pinning effect. Because on the roller some charged particles are pinned. That's why. And for electrostatic separation, the voltage is very less. But in high tension separation, the voltage will be very, very high. Unless until you apply very high voltage, you cannot ionize the air. You cannot never that. Otherwise, this air itself get ionized. You may get shocked. No. You need very high voltage to ionize the air, right? So that's why in high tension separation, you need very high voltage, like 50 kilovolt at least. Okay, there is another concept we can see. What are the conditions you require for electrostatic separation or high tension separation? The first condition is the mineral should be very fine in nature. The particle size of the mineral should be very fine. The mineral particles should be very fine. But is it advantage or disadvantage? Disadvantage, why? Because you need more grinding. You need more grinding. You need more grinding means more energy you are consuming. The cost will be more, right? That is one of the limitation. But for electrostatic separation or high tension separation, you need very fine particles, very fine minerals, small size particles. Second important point is they should be moisture free. I told you now, when you grind the mineral to very fine, automatically it will absorb the moisture from the atmosphere. It becomes agglomerates. And you understood, if gangue and velour minerals are together, you cannot separate them easily. So you need to remove the moisture. So you need to heat it, dry it. So drying is mandatory. Whenever you are doing electrostatic separation or high tension separation, you need drying operation before doing that to remove all the moisture. And another important point is size of the particle or weight of the particle. Suppose you want to do lifting action. Your particle size is coarser and it is heavy. It cannot lift it up easily because gravitational force is also working. Because of charge difference, they will attract. But due to heavy particles or due to coarse particles, it cannot be lifted up. So you always need small size particles and less mass. Mass should be less. So basically, you can do what? You can reduce the size. That can be done. You cannot change the density. No? Density of a mineral will remain fixed always. Is it fine? And electric separation is a universal separation. It can be applied to any kind of mineral. Why it is universal? Can you tell me, just think of it? You can charge any particles, whether it is gangue or whether it is valuable. And the point is, you take any mineral, if it contains 2 or 3 components, each component's conductivity is different from one another. You take any mineral, suppose it has 3 components. So component A, B, C. So A component conductivity will be maximum, B component will be just minimum, C will be less minimum. So all the components in the mineral have different conductivity. So difference in conductivity will help you to do this separation, right? So now I have one question. If you imagine the first type of separation, so tell me, you have 3 components, A, B, C. So A is having high conductivity, high electrical conductivity. And this C is having low electrical conductivity. So tell me which one is conductor, which one is not conductor. Don't take, I'll ask from the back bench. So you want to separate A and C by high tension separation. Tell me which one become conductor and which one become non-conductor. C become conductor. How many of you are agree with him? C become conductor and A become non-conductor. C become conductor. Very good. Because it will carry the charge. The charge will not flow to the drum or the roller. So that's why it will stick. The C will stick. But A will flow the charge and it will fall down there. So A become non-conductor, C become conductor. Very good. Okay, so this is over.